Unit 6, Day 5 notes. Today we're going to discuss finding the geometric mean. Geometric mean means to find the square root of the product of the two numbers. So we're going to find the geometric mean for the first few numbers. Again, it means to find the square root of the product. Product means to multiply. So if I multiply 4 with 9, it would give me 36. And the geometric mean will be the square root of that product. So when I take the square root of 36, I would get 6. What is going on with the delay? Alright, for the next one, let's find the product between 5 and 20. And you would get 100. And the geometric mean would be the square root of that. And the square root of 100 is equal to 10. Now notice how geometric mean is not the same thing as taking the two numbers, adding them, and dividing by 2. It's a little different. So now I need you to find the geometric mean between 7 and 8. I want the exact geometric mean, not a decimal approximation. Now we're going to find geometric mean in triangles. How many triangles do you see in this picture? You should see a total of 3. You have this small one right here. You have this small one right here. Excuse my highlighting. And then together they make up one big triangle. So if I were to break them apart and separate them, the big triangle has a hypotenuse of 5 and 16 combined together, which would give you 21. It has a leg of x and a leg of z. Again, hypotenuse is always across from the right angle. The medium-sized triangle has a right angle and a hypotenuse of z. A leg, the longer leg is 16 and the shorter leg is y. And for the small triangle, the hypotenuse is x, where the longer side leg is y and the short side is 5. And they're all similar. In a minute, we're going to be asked to solve for x, y, and z. And to do that, we would need to set up proportions, because if you've noticed, yes, there's 3 triangles in the picture, but you're missing a lot of information in order to find some of the pieces. So there are a series of proportions that could be used since they're similar triangles. First of all, what I would do is combine 10 and 4 so that you know what the larger side is, and that would be 14. So there's 2 ways to set up proportions. The first way is called through the middle. Through the middle, you have to always start on the longer side for the big triangle. In other words, the hypotenuse of the big triangle, again, always across from the right angle. And when you start there, you have to come either direction So I'm going to start at 10. You have to start at one of the parts on the hypotenuse. So I'm going to start at the part labeled 10 and then go to y. So it'd be 10 over y. And then from y to the last part, which is 4, is equal to y over 4. So that's one proportion that could be set up and could help you find y. To get to the other variables, we're going to use the mustache method. To use the mustache, you would start at 10 and go around the corner to x. So it would be 10 is to x. And then you go back around from x to the big side. So it is equal to x over 14. That's one corner of the mustache. And then there's another corner of the mustache that would set up a proportion as well. Starting at 4, you go to z. So 4 is to z. And then from z, you go back to 14. So z is to 14. So these are three proportions that could be created in order to find the variables. So again, you have through the middle, part to middle to part, or you have mustache. Part around the corner, come back around the corner to whole. And that's the mustache. So we're going to practice those methods in a second. Alright, for this problem we're going to solve for w, x, y, and z. And it wants us to do the Pythagorean theorem first, or see if we can. I could use the Pythagorean theorem for the medium-sized triangle because I have both legs, 6 and 8, and I would need to find the hypotenuse, which is x. If you recall the Pythagorean triples, one of them is 3, 4, 5. And then if I take each one of those side lengths and multiply them by 2, it would give me 6, 8, and 10. So the medium-sized triangle is 6, and I have 6 and 8, so that means the last side, the hypotenuse, x, has to be 10. Great. Now that I know x, I could figure out I don't think I could figure out y just yet, or z, or even w for that matter, because again I need some more information. So in this case, Pythagorean theorem will not be helpful. So I would have to use some other methods like the around through the middle. So through the middle would start me at 6 and take me to 8. So 6 is to 8. And from 8, it will go to y, as 8 is to y. And this I can use to find y. So let's begin. Cross multiply. I would have 6y is equal to 8 times 8, which is 64. And then divide both sides by 6, so y is equal to 64 divided by 6, which reduces to 64 divided by 2 would give you a 32 over 3. So that's y. Now, to find z, I could use Pythagorean theorem, or I could use the mustache. Let's use the mustache and set up whatever we have. So the mustache says I could take 6 to x, which is now 10, and back from 10 to the whole, which is w. And I can use that to find w. So again, it would cross multiply. That would be 6 times w, which is 6w, is equal to 10 times 10, which is 100. Divide both sides by 6. So w is equal to 100 over 6. And that would be 50 over 3 reduced. And the last mustache should help me find, well, now that I know what w is, I can use Pythagorean theorem to find z. Or use the mustache for the other corner to find z. But regardless, it all involves nasty fractions. So I don't believe there's an easy way out of this one. So part around the corner is to part. So y to z, where we said y was 32 over 3, is to z, is equal to, back around, z over w, which is 50 over 3. This is nasty, but we can do it. Z times z would give you z squared. And then we have to multiply 32 thirds and 50 thirds. 32 times 50 over 9. Ooh. You know, since I'm about to take the square root, I'm not even going to multiply those together. The reason I know I'm going to take the square root is because I have z squared, and if I want z singular, I'm going to have to take the square root of both sides. So square root, square root. When you have a fraction under a square root, you have to separate the square root sign into 2. So square root of 32 times 50 over the square root of 9. Now I have to look for my twin pairs. In the top, I already know what it will be for the bottom. So up top, 32 can be broken into 16 times 2, or 4 times 4, which is 16 times 2. 50 could be broken into 5 times 5 for 25 times 2. And then 9 is 3 times 3. So I see several pairs of twins in this, which is lovely. I have a pair of twin 4s. Again, one dies, one sacrifices himself. Or one sacrifices himself and one escapes. I have a pair of twin 5s. One sacrifices, one runs out. And then I have a pair of twin 2s. One sacrifices, one runs out. So at the top, I had a 4 come out, a 5, and a 2. At the bottom, I have a pair of twin 3s. One sacrifices, one comes out. So I have a 3 that came out. So multiply 4 times 5, you get 20. 20 times 2, you get 40. So 40 thirds. These were all fraction answers, except for x. Again, we're going to solve for x, y, and z, w, x, y, z. You can find z because z would be the leg of this medium right triangle. And since it's the leg, we have one other, the smaller leg at 7. The hypotenuse of it is 25. This is a Pythagorean triple. It's the Pythagorean triple that says 7, 24, 25. And so that means z is equal to 24, which is great. Again, if I didn't memorize that, I could use Pythagorean theorem and figure that out. So now that I know what z is, I can go through the middle to find y. So starting at z, go through the middle to 7. So z is to 7 is equal to, and then from 7 to the other part, y. 7 is to y. And I didn't mean to put z, I meant to put what it stood for, which is 24. Because it's not helpful if we don't have at least only one variable. If it has two variables, it's going to be difficult. So now we cross multiply to get our answer. So I'm going to multiply 24 and y, get 24y, and 7 with 7 and get 49. Divide both sides by 24. So y is equal to, is there a number that goes into both 49 and 24? I don't think so. 49, 7 goes into 49, but that's the only number I can think of other than 1 in itself. So I think that's as low as it's going to go, 49 over 24. Okay, so now we could use the mustache to find W. Starting at Z, 24, come around the corner to 25. So 24 is to 25. Start back again at 25 and come around to W, as 25 is to W. So now I cross multiply. I'll get 24W is equal to 25 times 25, which is 625. Divide both sides by 24, so W is equal to 625 over 24. And I don't know of any other numbers other than 5 and 25 that go into 625. So I believe that's as low as it's going to go as well. These are just nasty numbers. My lord. Alright, now I need to find the other part of the mustache to get X. Starting at Y, come around to the corner to X. So Y again was 49 over 24 over X. And then back from X, we go to W. Is equal to X over W, which was 625 over 24. Whew. Let's find the cross product. So X is to X, so that's X squared is equal to the product of both of these. So I'm going to say 49 24ths times 625 24ths. And then I have to take the square root of both sides. To get a singular x. So x would equal all 49 is a perfect square, 625 is perfect square, and then 24 times 24 is basically a perfect square. So at the end of the day, if I take the square root of 49, I'm going to have 7. Take the square root of 625, I'm going to have 25. And then I'll have 124 at the bottom because I have twins. I hope that shortcut wasn't too fast for you, but I'm trying to prevent you from doing a lot of work. So now I need to multiply 7 and 25 and then keep it over 24 as my final answer. And that's 175 over 24 for x. You could do this one and find A, B, C, and D. And that concludes your notes for the day.